Picture a muddy lakeshore in northern Kenya, 1.43 million years ago. 8 individuals walk across the wet sediment, their feet sinking deep enough to leave marks that will survive until today. You see their footprints, large, human-like, with a big toe aligned forward and an arch that distributes weight just like yours. But these are not Homo erectus. They belong to Paranthropus boisei, the Nutcracker Man, a species you've probably seen reconstructed as a short, solitary, ape-like creature with massive jaws. But the real answer is far stranger. These footprints tell us that Paranthropus boisei stood up to 1.8 meters tall, nearly 6 feet, and weighed around 75 kilograms. That's dozens of pounds heavier and almost 2 feet taller than previous skeletal estimates suggested. And they weren't alone. The tracks show 8 individuals moving together across the same lakeshore at the same time, all apparently adult males. This is the first direct evidence that Paranthropus traveled in groups, possibly in all-male bands, a level of social behavior we never expected from a species known only from skulls and teeth. So what exactly did these footprints reveal? The tracks were discovered in 1978 along the ancient shoreline of Lake Turkana, in what's now the Koobi Fora formation. For decades, they sat in museum collections, studied only as isolated impressions. But in 2026, a team led by Kevin Hattala of Chatham University, with researchers from the Max Planck Institute for Evolutionary Anthropology, Harvard, the Smithsonian, and the National Museums of Kenya, reanalyzed them using 2D and 3D imaging. They documented 21 footprints pressed into mud up to 12 centimeters deep, depths that indicate substantial body weight. The footprints' internal shapes, the way the toes splayed, the pressure distribution across the sole, matched previous Paranthropus boisei tracks. But their size did not. The largest prints suggested individuals close to modern human height, challenging the long-held image of Paranthropus as a small, stocky hominin. The team published their findings in the Proceedings of the National Academy of Sciences in July 2026. But surely this was just one unusual group. Maybe an outlier, not the norm? Here's where the evidence gets stronger. Nearby fossil remains and other footprints from the same time period show that 2 hominin species coexisted in this region, Homo erectus and Paranthropus boisei. The GAG-10 track surface, the specific layer where these 21 prints were found, has been dated to 1.43 million years ago using volcanic ash layers. The fact that all 8 individuals walked together within a restricted time span suggests coordinated group movement, not random individuals passing through the same spot. You might be thinking, how can footprints tell us more than bones? Bones tell you what a species looked like. Footprints tell you what it did. They capture behavior frozen in time. How fast someone walked, whether they traveled alone or in a group, how their weight distributed across their feet. The depth of these prints, up to 4.7 inches, indicates individuals heavy enough to compress the mud significantly. The spacing between prints shows a walking gait consistent with upright, human-like locomotion. And the fact that all 8 individuals moved in the same direction, on the same surface, at the same time, suggests social coordination. So what changed our understanding of Paranthropus? For over a century, Paranthropus boisei was known almost exclusively from cranial remains, massive skulls with huge jaws, thick enamel, and sagittal crests. These features earned it the nickname Nutcracker Man, implying a diet of hard, tough vegetation that required powerful chewing. Reconstructions showed a short, robust creature, perhaps 1.3 to 1.5 meters tall, built for strength rather than height. But the footprints suggest a different story. If Paranthropus individuals reached 1.8 meters, they were as tall as many modern humans, and taller than some Homo erectus individuals from the same period. This changes how we think about their ecology. A taller body requires more calories, different foraging strategies, and possibly different social structures. It also raises the question, why did Paranthropus go extinct while Homo erectus survived? The answer may lie in what these footprints reveal about behavior. Group travel, especially all-male groups, is a pattern seen in modern primates like chimpanzees and baboons, where males form coalitions for defense, hunting, or territorial patrol. If Paranthropus exhibited similar behavior, it suggests a level of social complexity previously attributed only to Homo species. This isn't just about size. It's about how these hominins lived, moved, and interacted with their environment. But how do we know these footprints aren't Homo erectus? The researchers acknowledge the uncertainty. The internal foot mechanics, the way the toes and arches pressed into the mud, resemble previous Paranthropus Boisei tracks. But the size overlaps with Homo erectus estimates. The team leaves the species attribution open, noting that both species coexisted in the region. What they can say with confidence is that these tracks represent hominins larger than average, traveling together in a group. This ambiguity is itself revealing. For decades, paleoanthropology has treated Paranthropus and Homo as distinct branches, one a specialized, robust side branch destined for extinction, the other the flexible, generalist lineage that led to us. But if Paranthropus individuals were as tall and as social as these footprints suggest, the boundary between the two becomes blurrier. New fossils have blurred many of the traits that once separated them, leading some researchers to argue that Australopithecus and Paranthropus should be folded into the genus Homo. So what does this mean for you? You're walking through your day, your feet pressing into pavement, leaving no trace. But 1.43 million years ago, 8 individuals walked across a Kenyan lakeshore, and their footprints survived. They were larger than we thought. They traveled together. They may have been more like us, in body and behavior, than we ever imagined. Your own footprints will vanish within hours. Theirs lasted 1.4 million years. What will they tell future species about you?